recording in progress. Okay. Okay, I think this is the perfect view. Okay. This is the first time I'm going to make an interview in English. So, again, excuse me if you don't understand me perfectly, but I'm going to do it as good as possible. That's it. That is okay.
My pleasure.
Okay. Okay. So, 3, 2, 1, and go. Good afternoon and welcome to the Vicente Fuentes channel. Today I have the honor of speaking with Avi Loeb, a theoretical physicist and professor at Harvard University, one of the 25 most influential people in the world in space science, and a member of the U.S. President's Council of Advisors on Science and Technology at the White House since 2020. Okay, we are talking about the president of the Council of Physicists and Astronomy of the National Academies of the United States, a person very important, director of the Institute of Technique and Computation of the Smithsonian Center for Astrophysics since the year 2007, and president of the Council of Physicists and Astronomy of the National Academies of the United States, the main forum for the discussion on the objectives to be achieved in the future of space science. Okay, his position gained international relevance when he published an article, a very famous article in the Exif magazine regarding the behavior of an interstellar object called Oumuamua, very famous right now, red in color and more than 100 meters long, and he has been in global news since then. With all his reports since his position as founder of the first interdisciplinary center for the study of black holes at Harvard University. Welcome, Mr. Loeb, director for the astrophysics at Harvard University to my channel. A real pleasure to interview you since I have followed your publications for many years, publications which have been an authentic revolution in the perspective of the study of alien life.
Thanks for having me. It's a great pleasure. We could have saved a lot of time if you just mentioned that I was born on a farm, so I'm a farm boy. That is a much shorter title.
Yes, it is a great title for you, but I think you were a very incredible person to explain very easy things that are very difficult for persons, but you explain this kind of things very easy to understand the mysteries of the universe. I think it is my opinion. Okay.
Thank you.
No?
Thank you.
Okay. Dr. Avi Loeb and me coincided as main speakers at the Ufology World Congress in the year 2021, I think. Yes, that is the year. And I was very surprised about his perspective on how to approach to the extraterrestrial life issue. It was very surprising to me how he explained this issue. He spoke about the philosophy of searching it, using a Greek term called xenia. It was very and innovative. It is the word. Well, it is no. I don't know if it is the word. It was like a concept, like hospitality. That is regarding what we can learn positively from an hypothetical alien contact. You were calling about Greek philosophers with that concept, xenia, like hospitality, and considering that this is exactly the essence of the real phenomenon of crop circle phenomenon in England that I have been studying for more than 15 years, teaching us, for example, this in the universal language of maths, concepts like, for example, wormholes to travel through the universe to Earth. All this by a supposed alien intelligence in different dimensions. With those words of your conference, I love this concept of xenia and hospitality as a way of approaching the investigations for the UFO phenomenon. That's it. And so in his conference, I had the opportunity, that's the destiny, to ask him about the phenomenon, the UFO phenomenon, in direct, in live. And that was a great idea, because he had an answer that was genial. He gave us an example, finding, for example, a bottle in the middle of a sandy beach. That is something that it stands out from the rest of the landscape. And if we see that, we might think that it is manufactured, and that manufacture has to be intelligent, and that fabrication must have had some kind of purpose, and we can't rule out that possibility. The same happened with its signal emitted into space, or its unusual body detected, I think. As human beings, I think, we can learn from such bodies or such emissions. It is a whole universe of possibilities that open us, including possible communications between species, and that I think that that opening of consciousness, that is the word, has a romantic point of view, because it is the search for the truth of the cosmos between different civilizations in different places in the universe. And I love that. Humans dream of discovering, and perhaps others will too. And in his words, I myself began to conceive another way of seeing the universe. It was very important for me. Okay. Well, Mr. Loeb, excuse me, because of this great introduction. Well, I have talked about a revolution in the extraterrestrial life researchers after your publication and your studies on Oumuamua, discovered in October 2017, and without any doubt, it is a challenge to apply the scientific method to understand what it really is Oumuamua, knowing that it is an anomaly in the solar system, and that the scientific community does not agree on its origin. How is it possible that it has that shape and that trajectory?
Well, over the past decade, we discovered the first interstellar objects. The first one reported was in 2017, and that was Oumuamua, and it didn't look like a typical rock in the solar system. It had a very unusual shape. It was most likely flat based on the reflection of sunlight. And as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. So that meant it has a very extreme shape, unlike a typical rock. And moreover, it was pushed away from the sun by some mysterious force because there was no evaporation of this object, no rocket effect. So that led me to suggest that maybe it's a very thin object, like a sail, and nature doesn't make thin objects that will be pushed by reflecting sunlight. And 3 years later, there was another object discovered with the same properties that did not show any cometary evaporation, and was nevertheless pushed away by reflecting sunlight. And the astronomers who discovered it with the same telescope in Hawaii called Pan-STARRS realized that it was actually a rocket booster that was launched from Earth in 1966. So we know that this second object, which is called 2020 SO, was artificial in origin because we produced it. The question is who produced Oumuamua. So that's the puzzle. But then also after that, we discovered two other interstellar objects. They were meteors, much smaller in size, of the order of a meter, that collided with the Earth and were moving too fast to be bound to the sun. And therefore, they were also interstellar objects. The first one was identified in January 2014, so 3.5 years before Oumuamua, and the second one was identified in March 2017, about 7 months before Oumuamua. So altogether, these are the three interstellar objects that were discovered first, and the two meteors appear to be tougher than iron, tougher than all the space rocks, 272 of them, in the same meteor catalog. So they were unusual because their material must be very different from the rocks that we had seen in the solar system. So what I say is the first three interstellar objects appear to be unusual. The meteors are tougher than all the space rocks, and they could have been a spacecraft. They could have been made of some artificial alloy. We don't know. And Oumuamua had a very weird shape and was pushed away from the sun, presumably by reflecting sunlight. So altogether, this is a message we get from interstellar space, that the objects that come to us into the solar system from outside are not what we have found in the solar system in the past. And we are planning an expedition to collect the fragments of the first interstellar meteor in a couple of months, and we hope to tell if it was a rock of some unusual composition, or maybe it was a spacecraft.
It will be an incredible mission, I think, no? Isn't it? But there has been talked about a possible iceberg driven by nitrogen, similar in composition to the surface of it on Pluto planet. It is 0.5% in composition, and that this was the reason why it was only detected leaving the solar system. But computer models from the University of Arizona have not been able to explain why its mass is like that. That is very interesting to to investigate. In fact, excuse me. In fact, Mr. Loeb, there would not be enough nitrogen to generate a body like Oumuamua, since it would take 1,000 times of the total mass of stars in our galaxy to generate those planets like Pluto, from which that material came out. So that explanation would not make sense. But even so, if it did, we would be facing an inconceivable piece of engineering when it comes to creating a possible body with that shape and that fuel. Someone could have designed it in that way. Someone foreign to Earth. So, Mr. Loeb, is the Oumuamua issue resolved? What possible secrets do you think may it reveal in the future?
Yeah, it's definitely not resolved, and the possibilities mentioned by mainstream astronomers have problems, as you mentioned. There is not enough nitrogen to account for objects like it at a large enough abundance. The mass budget is not enough, as you mentioned. There was another suggestion that maybe it was made of hydrogen that evaporated, but the problem is hydrogen would not survive the journey. It evaporates too quickly. And then there was a suggestion maybe it's a cloud of dust particles, 100 times less dense than air, and that would not survive coming close to the sun if it's a very fluffy dust cloud. And so I would say that actually a possible design that is technological is a viable possibility, not less likely than anything else. And the best way for us to validate this versus natural origins would be to get better data. If we had a photograph of the object, we would be able to tell. And so the key for the future is to find more objects like Oumuamua and take a close-up photograph of them. And we hope to do that in the coming years, because there is the Vera Rubin Observatory that will have a survey of the southern sky with a camera of 3.2 billion pixels, and every 4 nights, and it will definitely reveal more objects like Oumuamua, and we can take a close-up look at them. Of course, there is also the possibility of looking for objects closer to Earth, because the US government talks about unidentified aerial phenomena, and I established the Galileo Project, and we built an observatory that will monitor the sky and look for objects and use artificial intelligence to tell us whether they are natural, like birds, bugs, or maybe human-made, like balloons or drones or airplanes. And the question is there anything else? Because you can imagine Oumuamua being a mothership that releases small probes that go into all the habitable planets. And the question is, do we have anything in our sky that we would notice at a close distance? Because at large distances, our telescopes are not sensitive enough to see, for example, a CubeSat that is 10 centimeters on a side. We cannot see it until it enters the atmosphere and comes really close to us. And then it will become an unidentified object that we have to figure out what it is. So that is the purpose of the Galileo project. And we are planning to go along 3 branches. One is to look for the fragments of the interstellar meteor that I mentioned before. Another one is to follow an Oumuamua-like object to date the next Oumuamua. And the third one is to look for unidentified aerial phenomena that the government is talking about and figure out if any of them could have been extraterrestrial in origin.
I think the Galileo project will be very exciting to do it because of I think it is an enigma regarding all this issue, because I believe there is the possibility of the existence of other Oumuamuas that perhaps have evaded us by having even longer hyperbolic trajectories, entering and escaping our solar system.
Well, it's not just the trajectory, but also the speed. If an object moves very fast compared to rocks, astronomers would never monitor such objects. The speed of rocks in the solar system is 10,000 times smaller than the speed of light. And if you imagine spacecraft moving much faster than that, astronomers would not capture them because they will have only one frame that shows an object, and they would say, well, maybe it's a fluke. And so we may have missed very fast moving objects, but also small objects that are typical of the probes that we send to space. Oumuamua was the size of a football field, very big. We never sent a spacecraft as big as Oumuamua. So it's quite possible there are many more objects, smaller in size than a football field and moving faster that we missed. And it's a new frontier that we should build telescopes to improve our knowledge of what is passing near Earth and whether there is a smarter kid in our cosmic neighborhood.
Well, there are new frontiers, but there are all frontiers, but that are not resolved yet. For example, I am talking, for example, about the origin of the famous extraterrestrial emission called WOW, W-O-W, discovered in the year 1977. We're talking about the best candidate radio signal by the SETI, the institution, the Institute for Extraterrestrial Research, ever captured with our telescopes due to its strange, really strange characteristics. It was at a frequency of 1120.4056 megahertz in a frequency associated with the chemical element of hydrogen. I don't know if it is
yes.
hydrogen. Okay, this form of spatial communication would be logical if you want to perform a broadcasting. If you want to perform a broadcasting, for example, an emission since if if it would not have any background noise, and it would be perfect for communicating with other civilizations as well as with your own, I think.
Yeah. The only thing to keep in mind is this signal was only at one time observed, and some people suspect it may have been a fluke. And one thing to keep in mind, for 70 years, the SETI community was searching for radio signals. And that is just like waiting for a phone call at home. You need the counterpart to be active, someone to call you. And there may be nobody that tries to call you, and you may miss the call. Maybe the call arrived millions of years ago when we were not around. But the approach that I'm taking is different. It's like checking our mailbox for any packages that arrived, because even if the sender is not alive, the packages will still accumulate in our mailbox, and they will tell us if someone is out there. And it's just like doing archaeology, where you find relics of civilizations that may not be around anymore. It's a completely different approach, and this is something that was never attempted in the past through a scientific research program. So we are embarking on virgin territory, and I hope that we will find some low-hanging fruit.
Mm-hmm. I think it is essential to talk about this because of the frequency of the hydrogen, the most abundant element in the universe, something that any advanced extraterrestrial civilization from our galaxy, the Milky Way, would know about, and would also be a perfect way to attract the attention of someone who could listen for both good or bad. Always that that kind of questions, if it is a good calling or a bad calling. Well, I think Stephen Hawking always was talking about we should not call the space. Okay, no?
Yeah, but I disagree with that because I think we had our science and technology just for one century, and that's a small fraction of the age of the universe. And most likely other civilizations are far more advanced than we are, because most of the stars formed billions of years before the sun. So if there is any technological equipment that arrives to our doorstep from far away, they did not have us in mind, because it takes 50,000 years for light to traverse the Milky Way galaxy, and therefore a spacecraft that moves 10,000 times slower than light would take 500 million years to reach us. So when it left originally, it didn't have us in mind. We were not that interesting. We didn't exist as the human species, and they must be much more advanced than we are if they reached us, because we never reached them. And so I would argue that we can only learn from the encounter.
Of course.
We will see technologies that represent our future. So we should not be worried about the risk from looking for. But at the same time, we should not transmit carelessly signals. I mean, we can just search our sky in a passive way using telescopes and just check if there are any probes that are in our vicinity. So that's my approach.
I hope so. It is not a risk. Recently, Dr. Loeb, a new study published in the International Journal of Astrobiology suggests that a potentially habitable sun-like star called 2 mass 1928 located 1,100 1,000, excuse me, and 800 light years out from our sun could be the source of it. And there lies the big unknown question. Did it came from a natural event, or someone sent it on purpose? It was, if it was a natural event, it has to be huge, as it would have traveled so much within our universe. Being so, Dr. Loeb, and knowing that this star only has, 5 degrees more than our sun and almost equal radius and luminosity, would it be possible that this signal came from there, from any planet from there?
Well, it's possible, but to verify that it came from a particular source, we need to see it again, because it's also possible that it was just interference on Earth. And there was recently, about a couple of years ago, there was a detection of a signal that came from the direction of Proxima Centauri, the nearest star to us, and then it turned out to be most likely interference by sources here on Earth. And that's the real risk of claiming a signal from space, that we are producing transmission at those frequencies. Yes. I would argue that we should continue to search for radio signals, of course, but we should keep in mind that radio communication represented very primitive technology that we developed here on Earth for communication. Now communication is done through optical fibers, and in the future, hundreds of years from now, it's not at all clear that we will use radio waves to communicate or to do anything with. So it's a little narrow-minded of us to imagine another civilization exactly at the same technological phase as we are right now, because our science and technology is only a century old. And 1 century is only one part in 100 million of the age of the sun. So it's really unlikely to find another civilization exactly at the same phase as we are. And if it's much more primitive than we are, we have to board the spaceship and visit their planet and start searching through the trees for them, because that's the way we were tens of thousands of years ago. But if they are much more advanced than we are, we don't need to do much. Instead of going there, we can look around and see if any of their probes arrived to us. So that's much easier, and that's what the Galileo Project is searching for.
Okay, I understand absolutely, and but Mr. Loeb, what would it, if so, its purpose, internal or external communication? It might be a very good target to try to look for example, exoplanets there, but why send the signal? Wow, always that motivation, those kind of exciting questions, no? But for example, could it be a Trojan horse, for example, a trap or a salvation for the humans in the future, if we could manage the space travel?
Well, so space travel is different from radio signals, because radio signals can only communicate. They can only tell you that someone else exists. And it's not at all clear that other civilizations would use it, because they will have no benefit. It takes a long time to hear back. The other side of the Milky Way galaxy is 50,000 light years away. So we have to wait 100,000 years to hear back a response to any signal we send to the other side. And you need a lot of patience for that, and it's not clear that anyone would like to engage in that. More likely you will detect some leakage of radio transmission that was not intended for us to to detect. But on the other hand, if you find probes, if there are physical objects that were sent, they can pursue some important tasks, because just like in biological systems, you have seeds that are sent, like a flower, like dandelion sends seeds, and this way the flower multiplies and creates copies of its DNA. And you can imagine another civilization sending out objects such that they would preserve whatever DNA, intellectual DNA they want to preserve, and they can equip them with 3D printing capabilities and artificial intelligence, so that these would be completely autonomous probes that are self-replicating, just like seeds of a flower. And this way, a civilization can spread throughout the galaxy. Just a single civilization can do that. I calculated that we are spending right now $2 trillion on military budgets worldwide every year. And if we were to listen to John Lennon, who said, imagine all the people living in peace. If we were to adapt that and would live in peace, instead of wasting money on killing each other or defending us against other people, we would invest all of it in space exploration. We can send one CubeSat to every star in the Milky Way galaxy within a few decades, just a few decades. So humanity can do that. You can imagine another civilization deciding to do that. And the purpose, the goal of that would be to preserve copies of what we care about, to carry those precious ideas or goals that we have here on Earth, realizing that the conditions on Earth will deteriorate. The sun will burn up the surface of Earth within 1 billion years. So if you want to maintain some monument of the human species in the future, you want to send them into space, and you better do that with artificial intelligence and 3D printing capabilities, and you send it everywhere and into the habitable zones of other stars where you have the nutrients, you have the water. And so that would be a very natural goal that an advanced civilization would have. And to find out if other civilizations had that goal already billions of years ago, the only thing we need to do is look around us and search for those objects. That's very different than searching for radio signal, because with a radio signal, what can you accomplish? The best you can do is say, I exist, or here I am, or, that is not a very productive endeavor, because you're not preserving anything. And if eventually the civilization will die because of some catastrophe, then there are only these radio signals that go out, and there is nothing left behind. So I think it makes much more sense to send physical objects.
Yeah, but for example, Mr. Loeb, there is a mystery around the fast radio bursts, the FRB, discovered in the year 2007, fleeting radio pulses that last just a few milliseconds.
I wrote the only paper in the scientific literature that suggested that these fast radio bursts may be technological in origin. But what you need for that is to use a huge amount of power, all the power that arrives from the sun to Earth. If you imagine this being technological, and that would be a huge amount of power, but in principle, it's possible. Yes, I wrote a paper about that about 5 years ago.
Yeah, but always outside the Milky Way. Several possibilities
in the universe.
Several possibilities have been given to try to explain them, from rotating neutron stars to black hole activities, for example, or even some kind of activities of UFOs, of unidentified flying objects, according with technology that we would not yet be able to understand. But in this last explanation, there is a mystery because more than 100 of these fast radio bursts have been detected, but they are widely dispersed, very dispersed in the space. That is from different locations, very far from each other. Could this mean that different extraterrestrial civilizations could exist, each one having appeared like a flower, as you said before, in different parts of the cosmos independently? That is?
Yeah, so as I said, I wrote a paper about that. I discussed it. The only paper in the literature that talks about fast radio bursts from cosmological distances that are technologically produced. By the way, we are into 40 minutes by now. Mm-hmm. So it's more than half an hour.
Mm-hmm. Oh, okay. Excuse me, Mr. Loeb. Well, I think I always speak a lot in my interviews. I could be speaking for the whole day, but well, it has been very well. It has been incredible. You to be in my program, and I am very well. I don't know how to say it, but in this moment of my life, it has been very important to make this interview. So thank you very much. That is.
Thank you for having me. It was a real pleasure, and I enjoyed your questions and insights.
Okay, excuse me because of my low level of English. If it is possible in the future, we could continue with the rest of the questions, maybe in the future when you want. And I will try to explain English a little bit better. But okay, thank you very much, Mr. Dr. Avi Loeb, and well, that's it. Thank you very much. That's it.
Thank you. Bye-bye.
Okay. Goodbye. And well, this is the final of the program. And as I always say, in one life, there is many lives. Goodbye.